Alright, welcome back. So we are in chapter 6 part 4. Okay, we were looking at this example in the previous clip. So when we discount each cash flow separately to present value, and then we add them up. So the principle again here, you can only add or minus. It depends on the cash flow. You can also minus if the cash flow is negative. So here these are all positive cash flows, therefore you add them. So if you have negative cash flow here, then this will be a negative, so you add, so you minus this cash flow from the total cash flow, right? So this is an important principle. You can only add or minus cash flows that are at the same time value. So you cannot add across like this because they are at different times. But once you have brought these cash flows to the same time value, not present value per se, but here these are all present value, but the cash flows need to be at the same time, point in time or same time value, then you can add them. If they are different times, you cannot add, because the value of 200 here is different from the value of 400 here. They are not the same. Okay, but here 178.57, okay, this is a different amount, but the value is at the same time, therefore you can add the value. Okay, the value is not the same, but the time value is the same. They are at the same point in time, so you can add these two. Okay, so here it means what this answer means is that this cash flow, this stream of cash flow, 200 at the end of year 1, 400 at the end of year 2, 600 at the end of year 3, and 800 at the end of year 4 is worth the same as $1,432.93 now, given the interest rate of 12%. It's not stated here, but this is 12%. The interest rate is 12%. This stream of cash flow is equivalent to this value of cash flow now. Okay, that is the implication of this example. Alright, let's go on to the next slide. Alright, next we are going to skip this next 3 slides because I've shown you how the cash flows can be solved using spreadsheet. I've shown you earlier, so I'm going to skip this. Okay, and I'm also going to skip this. This is another example. You can go through this on your own. Okay, it's similar to the example that we have seen earlier. To save time, I'm going to skip this. Okay, I've also shown you how to use the financial calculator. But I've shown you the financial calculator application. I've not shown you the financial calculator here, but the application is just as efficient, or the same. So you can use that. Alright, let's look at this summary. It's actually a summary of this part, where you have to make decisions. So let's look through this example. Your broker calls you and tells you that he has this great investment opportunity. So if you invest $100 today, you will receive $40 in 1 year, after 1 year, and $75 in 2 years. If you require 15% return on investment, this is the interest rate, 15% return on investment of this risk, should you take the investment? So if you take investments like this, which is slightly risky, you would want a return of 15%. That's what it means. Now note this, here you need to look at the elements in this time value of money problem. Alright, so here there are several types of cash flow. So you have this $100 here, $100, and then you have $40 here and $75 here. Don't confuse the two. This $100 is what you invest, so it's actually a cash outflow. And this $40 and $75 are cash inflows. This is outflow, these two are inflows. So you need to look at this separately. Don't add these together. So this is what you put in, this is what you get out of what you put in. But you get this out later. You put in now, right? So this $40, without computing, you cannot say you receive 40 plus 75, that is $115. You invest only 100 now, so it is better to invest. You put in 100, you get 115. But that is wrong. Yeah? Why? Because you cannot add this with this, and you cannot take the sum of these two because they are at different time values, and you cannot compare that with $100 today because this is again at a different time value. Yeah? Therefore, if you want to compare, you need to bring them to the same time value, yeah? To the same point in time, yeah? The value of the cash flows. So how do you do that? Yeah? There are various ways of doing this. Okay, the first way is to take the present value. Yeah? That is why we consider this example in present value. Okay, now to do this present value, look at the elements in this problem. Yeah? So we ignore this for the moment. Okay, this $100 for the moment. This is $40 1 year from now, and $75 2 years from now. So this is a stream of cash flow. Yeah? There are two cash flows, multiple cash flows. Okay, and the term is 2 years, yeah? Because this is over 2 years. Okay, and the interest rate is 15%. We are given that. Yeah? So the question is, should you take the investment? Yeah? You will take the investment when the value of these two cash flows now, okay, that means if you take this present value 75 plus 40, yeah, the present value of these two at time 0, yeah, if it is greater than $100 now, this is what you pay, this is what you receive, right? So if it is greater than what you pay, then it is worth your investment, yeah, because you get more than what you put in, yeah. But if you put in more than what you get, then it is not a worthwhile investment. Alright, yeah, so that is the basic idea of present value. So let's look at how this can be done. Yeah, so you take $40, you discount this over 1 year because this occurs at the end of the first year. This one occurs at the end of the second year, so you discount this over 2 years at 15%. Yeah. Now this is the value of $40 at year 1 and at the end of year 1, but then when you discount this, this becomes the value at time 0. Likewise, this becomes the value at time 0. Yeah? So now you can add the two. You cannot add 40 with 75, but you can add these two because this has been adjusted for time value. They are at the same time value. Yeah? So you can add them, you get $91.49. This is the present value of your benefit, okay, what you derive. Yeah, so this $40 and $75 that you get, yeah, from the investment is worth only $91.49 now, but you pay $100 now. Therefore, you pay more than what you receive. Yeah, therefore, it is not a worthwhile investment. So you should reject the offer. Yeah, it's not such a great investment after all. Is that okay? Alright, this is one way of solving this. Yeah, another way would be you can take the future value. Yeah, this is not an ideal method, but I'm showing you this because the same problem can be solved using different methods. Yeah, so you need to be aware of this. Yeah, for example, yeah, here we take present value, here we take future value. We can solve this using future value method as well. Yeah. So what we do is we take the future value of these two cash inflows, the benefits. Rather than taking the present value like we did here, we take the future value. 40 multiplied by 1 plus 15%. This will give you the value of $40 at the end of the first year. Sorry, at the end of the second year. Yeah. Because it's at the end of the first year, you compound for 1 more year. Here we discount, here we compound. Yeah. So this will be the value of the cash flow at the end of the second year. Then you plus with 75, which is already in the second year. Yeah? So you don't compound this. This is already at the end of the second year. So these are two cash flows. Now the value of these cash flows are at the same time value. So you can add them. Okay, so you get $121. Yeah? This is the future value at time 2 of these benefits, yeah? Of these cash flows. Okay, now what is the future value of this? Yeah? Because if you want to compare this, you cannot compare with this, yeah? Because this is $100 you invest today, this is time 0, this is time 2, yeah? End of year 2. This is the value of these cash flows, these two cash flows at year 2. You cannot say this is greater than that, therefore you should take the investment. No, yeah? Now what you do is you take the future value of this as well, 100 multiplied by 1 plus 15% raised to the power of 2, because you want to bring this is present value, you want to take the future value of this at the end of year 2, so you compound this over 2 years at 15%. So this is the formula, 100 multiplied by 1 plus r raised to the power of 2, you get 132.25. Now this is the future value of your benefit, this is the future value of your cost. Your cost is higher than the benefit. Therefore, again here, you would reject, because the cost is greater than your benefit. So the two decisions are consistent. The answer seems different, right? But the decision is the same. As long as you are consistent. You can use present value as we did here, or you can use future value as I have done here. So either method, if you do it correctly, you will come to the same consistent decision. You cannot go wrong if you do it correctly. Alright, let's move on to the next. Okay, saving for retirement. This is also, I'm going to skip. Okay, it's just another example. You can do it on your own. Okay, now we come to the end of this part. A quick quiz of this part. Suppose you are looking at the following possible cash flows. Year 1, 100. Year 2 and 3, 200. Year 4 and 5, 300. That means year 1, 100. Year 2 you have 200. Year 3 also you have 200. Year 4 you have 300. Year 5 you have 300. The required discount rate is 7%. So the question is, what is the value of the cash flows at year 5? So when you say year 5, this is at the end of the last cash flow. So we can call this, the first problem is to determine the future value of all these cash flows. Okay, at 7%. Now if you look at the second question, what is the value of the cash flows today? So you want to determine the value of these cash flows now at time 0. Now third question is, what is the value of the cash flows at year 3? Somewhere in between. So let's look at the first one. What is the value of the cash flows at year 5? So what did we learn? We learned that we can take the future value of the individual cash flows, take it to future value, and then you add them up. So the value at year 5, I don't use future value. Just put value at year 5 is equals to 100. You compound this at 7% over 4 years, because it's at the end of year 4. Sorry, this the end of year 1. Okay, so you want to compound this to the end of year 5. Therefore, you compound this over 4 years. 5 here minus 1. This is the cash flow at year 1, end of year 1. So you compound this 4 years. Plus 200, you compound this same formula, 1 plus 7% multiplied by 1 plus 7% raised to the power of 3. 5 minus 2. Because this cash flow occurs at the end of year 2, you need to compound this only 3 more years. This one you compound over 4 years, this is 3 years. Then the second 200, because this occurs at the end of year 3, you compound over 2 years, to bring it to the 5th year, And then the 4th and the 5th, you do it the same way. Okay, this one you compound for 1 year, this you don't compound, because 5 minus 5 is 0. Anything raised to the power of 0 is actually 1, So this is just 300. Because this 300 occurs at the end of year 5. Okay, and therefore you don't need to compound. You just add them. But I'm just showing you the formula so that it is complete. So you get 1226.07. What does that mean? It means that the stream of this cash flows, 100, 200 at the second year, 200 again on the third year, 300 at the end of 4th year, and 300 at the end of the 5th year. They are all worth this much at the end of the 5th year. Okay, if you deposit these cash flows in an account that earns 7%, at the end of year 5 you will have $1,226.07. So that's the answer. Now let's look at the second question. We're coming to the end of this slide. Okay, but let me show you the equation.